And I was very proud of that, that the API actually worked. So you can do all sorts of stuff. And so hopefully you guys take advantage of that, because it's something, you know, just to expand what can be done and what people can do. Yeah. So a lot of this kind of came from Jeff, because he wanted to make it easier for more of you guys to hack on the badge, whereas I wanted to actually make it harder and more challenging.
Yeah, so software guys,
Yeah, for software guys. There's a lot of software guys out there, right? How many people like use software? A lot of people. Yeah. And so you can use, you can even use, whatever to send stuff to a COM port. Doesn't matter what operating system, doesn't matter, you could use an Arduino if you're into Arduino. So here's a little description of it. You plug the USB in, it's going to detect an FTDI USB to serial adapter. You probably don't need any drivers if you've installed any sort of USB to serial adapter before. If you do, you can just click yes, download drivers, because, I don't know, they're there. It should be easy and seamless. You plug it in, the badge is going to give you a little welcome string in ASCII, and then here are the commands. You can clear the frame buffer, which is in RAM on the device. You can load different bytes into the frame buffer, and then you can update the display, and that will give you your update, and then you hit X to exit it, or you just take the battery out, and you'll get an ACK after each command. Now the tricky part is that the commands are actually in ASCII, but then for loading the byte, you have this load byte VV into frame buffer location AA. So you have to look at this next page, which is the memory map for the actual display, which isn't your typical matrix like that. So maybe somebody wants to write a little wrapper to handle that, but I couldn't figure it out. So you have to load, you have to look at the memory map of the LCD and then load your data in hex bytes. So you have your, in non-printable ASCII, so you have your ASCII character and then the 3 non-printable ASCII hex bytes. So that's the only tricky thing. So you can't really only be in hyperterminal the whole time. Yeah, so check out the data sheet, which is also on the CD. And here's the memory map. So those are like the only 2 core functions. We want to keep it really simple. Like there's previous year's badges, I felt like we provided so much stuff, it was hard for people to figure out like what they wanted to hack on and everything, and sort of force feed you features. So then this year we tried to go the other way, of like force feed you capability, and then you guys can figure out what to do with it. So there's all sorts of secret modes. We had, in March, we did this call for integration, and we're basically like, what can we do to involve people more and not keep it just like, Joe locked in his office talking to Jeff once in a while.
Yeah, so the idea here was that we want to try to make the badge more central, and we've got memory on it, and it's something everybody's basically going to, unfortunately not everybody, but basically the majority of everybody will have. So if we're going to put a secret on there, or a clue, or a certificate, or we're going to do something, why not besides us having cool stuff on there, why not let everybody else that we trust in the contests put clues on their other areas? And try to make it more central to a lot of different things you're going to do, and just max out the RAM.
Yeah, and so there's a lot of stuff on there. Some of it I don't even know what it is. We just had people say, put this chunk of data, or hide this string, or do this, or do that. So I'd work it in to where it would seem relevant to do. And a few people have found things, but there's a lot there, and you can get the benefits of different contests.
The best was it Space Rogue?
Oh yeah, is Space Rogue here? I guess he wouldn't admit it anyway. So we took all these submissions from people, and we decided which ones were cool that people would really enjoy. And so Space Rogue from Hacker News Network was like, yeah, I want to give away a free T-shirt. We're like, all right, you're cool. We go way back from the loft and everything. So we put them in, but we want to keep it all secret. Like we figured, people would hide data and not tell anybody. So as soon as I was like, yeah, we'll put your data in, he like sends out a tweet and like his HNN, like all over the place. It's like, fine, DEFCON's gonna hide data. And we're like, you totally just like blew it. And I made up a whole story and told him that Jeff was really pissed and that we were going to take it out and everything. And he profusely apologized.
That's funny because I never heard from him.
He's just like, sorry, dude. Yeah, so we tried to keep everything secret. And actually, I'm going to tell a story that might embarrass 2 people here. I don't think I've ever met them in person, so that's why I'm going to say it. So one of the things was this guy that was like, yeah, man, I'm going to actually propose to my girlfriend. And I want to do it through the badge. And I'm like, yeah, I'm like a sensitive kind of guy, I'm like,
you're Joe.
I got goosebumps and tears and everything.
Yeah, and you're Joe Smooth.
Yeah, and I'm known to be pretty suave with the ladies.
Swash.
Yeah, so I was like, that's cool. That's a good way to propose. And
well, he couldn't get the airplane with the streamer behind him.
Right.
Yeah.
Because you can't see it from inside of the riv. So we were going to integrate like this, secret message of some sort for the person to find, and he would propose, and we probably would have made like a big production out of it, and he probably would have come up here and stuff. So we had him on the list, and then as I started integrating stuff, I emailed him. I'm like, all right, man, what should we do? And he's like, actually, there's a little problem. We broke up. And then I got an email from his ex-girlfriend that had said, it was something basically the same thing. It's like, sorry, or whatever. I don't even know how she knew that he was going to propose to her unless she was like reading his mail or something. It was actually really strange. I was like, oh, that totally sucks. And he's like, well, maybe you can write, maybe you can put in this poem or something. I'm like, no. It was like a love poem. Because like wedding proposal is okay for DEF CON, but like groveling love poems, not okay. So that didn't make it in. It's unfortunate. Okay, so some other badge stuff. These are things sometimes I forget to say. So other stuff you might want to know. If you don't want to know it, you can leave. I won't feel bad, because there's other talks going on soon. And actually, we're going to end up with a lot of extra time anyway, so you won't miss your next talk, really. We're actually going to be able to have questions and answers here, too. Okay, so the development environment is the exact same as last year. It's the Freescale Code Warrior for 568000. Special edition's free for up to 64K of flash, and we only have 16K, so totally free, like beer. And it's not open source, which people always complain about to me, but the tool was chosen, the part was chosen for a reason, and the tool kind of follows along with it. And Freescale was nice enough at least to make it free, as opposed to charging us money. And it is Windows only, works fine in VM. All the tools are on the DEF CON CD, so you don't have to go to the interweb or anything to download the tools. The one main part that's really cool is Processor Expert, and I mentioned this last year, where basically it's this GUI for configuring the peripherals. And everyone loves GUIs, and no one loves configuring peripherals. So it's like a perfect match. Basically, it takes care of doing all of the low-level drivers and interface functions for timers and serial port and PWM and everything, so you don't have to actually do a lot of the setup. You can just select your bean, which is what each module is called, configure your bean, and then drop it into the code. You generate code, and it will generate it. So that if you're not a low-level embedded guy, you can still develop stuff. And I use the beans. I use Processor Expert, so if you load up the source code that's on the CD, you'll be able to see like how everything's configured. Who's planning on hacking their badge for the badge hacking contest? 3 people.
No.
Seriously? More. Are there more? 5, 6, 7, 8, 9. Okay. 10. That's good. We're going up in numbers. So this might interest you. The serial static bootloader static serial bootloader we had last year, except this year it's easier to use, because last year we just had test points and you had to wire up a bunch of stuff. This year we have the mini USB port right there for your use, and all you need is a USB port and a terminal program, and you're good to go. You can load your code right up on the badge. To enable the mode, hold SW1 and SW2 on power up. What I like to do, since you need to have your computer plugged in, remove the battery and then make sure it's off, and then just plug the device into the computer. And that way, the unit's going to come up. No batteries there. You don't have that switchover problem of maybe the badge still being on and you're not able to get into the bootloader. So just hold down SW1 and SW2 on power up. Both LEDs are going to come on. Virtual COM port's going to appear, and you're good to go. It's waiting for the bootloader. So you use your dev tools from Code Warrior, modify your stuff. There's a few caveats with that, though. When you're modifying your code, you have to make sure that if you change the vector table, you have to make sure that you change the reset and the COP vectors to point to the bootloader, which are the first 2 in the vector table. Otherwise, when you reflash your code and you go to run it, it's going to jump right to your user code. But if for some reason you brick something or you want to reload something again, you can't, because it's never going to get back to the bootloader. So make sure you change that. And if you end up bricking it, there's a way to do it. But read the details in CPU.c. And for those who did it last year, you're familiar with it already. It's 9600 baud, and use your elf.s output file, and it takes like 90 seconds to load. But it's cool because you don't need any hardware at all, like any external hardware. And that was the real key, is trying to do something like, we can't make it much easier than that. But in case you totally screw up and brick your badge and forget to change the vector tables or just do something and completely clobber it, there is the JTAG interface on there as well, and that's where that 7x2 row footprint is. I have about 100 of the connectors that I'm carrying around with me, and I'll, if I don't get accosted on the way to the hardware hacking village giving them out, I'll leave the remainder of them up there. And you can just solder them on and use the USB tap hardware which is also what we used last year. There'll be a few of those up in the hardware hacking village, and you can just completely load the flash back on, which is the DC18-with-boot, which is the bootloader. So it's cool. So there's two ways to do it, and it's just very, very simple. All right, so say you want to create your own graphics and like put porn on the badge or something, which if you do, you might score very highly in the badge hacking contest, if I have anything to say about it. So you can load your own graphics. Basically, it uses at least this is how I did it. If you are into software and stuff, you could probably do it a different way. But I use the Kent display tool, which comes on the CD, which was designed for 132 by 64, their older display. But basically what you do is you convert the bitmap to an array, and then you cut off a bunch of the bytes that aren't used to get to your 128 by 32 pixel size. So you convert the image, and then you use your tool, and then you erase the unused bytes, and then you copy the data into the array.
So you said older badge. Does the newer one have more pixels?
No. So this was one of their, actually I shouldn't even say older display, just for a different display that's bigger. That wouldn't fit on the badge. It was like way too big.
Oh, so that's why it's trimmed.
So they don't have, this part is so new, the 128 by 32 that we're using on this badge is so new that they don't even have the right development tools set up yet. So we're making use of the old ones. And actually I think they're coming out soon, but it might be too late for DEF CON to use them. But this way is totally fine. So here I even made a little step-by-step graphic. I had a lot of time on an airplane when I made these slides. So choose your source file, which is going to be your image. It has to be 132 by 64. Otherwise, if it's not 132 by 64, it's going to give you an error. Then you just generate the C array, and it says C array generated. And then if you compare what one should look like on the left to one that you get from the output on the right, you have those 4 extra bytes at 4 different locations. So you just cut those out. They're all FFs. And then it looks like that. And then you just load that code in, and you're good to go. So here's the power consumption stuff. So we're using a CR2032 lithium coin cell, which this is sort of the battery of choice for badges because it's small, it's thin, it's cheap. DEFCON 14 we used 1, DEFCON 15 we used 2, DEFCON 16 we used that gigantic photo battery, and then last year we used the CR2032. But the problem is it doesn't like high current consumption, and it's only really good for things that are very, very low standby current and things that maybe have a little pulse for a second. But so that's the challenge, is trying to get the power consumption down to a point where the badge would be good and useful for at least the time of DEF CON. And this time we finally exceeded it. So in idle mode, when you're not doing anything, it draws about 700 microamps, 0.7 milliamps. The only power consumption at that point is the microprocessor, and it's in a sleep mode, but it's not in the lowest sleep mode. Because it turns out if you put it into the lowest sleep mode, you're reducing the clock to 180 kilohertz or something like that. And then if you try to debug without bringing the device back into its normal clock, and you try to write to flash at 180 kilohertz, you could completely screw the flash, physically damage the flash, which we ended up doing a few times along the way. And luckily, John Winters, one of the guys from Freescale who helped design the chip, came to DEF CON last year, and he's an old school MIT hacker and everything, and one of the few people that actually also does work on Memorial Day weekend and holidays and stuff like that. So when I encountered this problem, I'm like, wait, the sleep mode isn't working, and now I can't reprogram my badge or anything. And I call him up, and he's like, hey, he just happened to be home, and we spent the weekend troubleshooting this whole thing and debugging stuff and getting it working. But that was, who knew that you could physically damage flash using a debugger? I had no idea. So in idle state, which it normally is always in idle, it's just sitting there sleeping. In active mode, once you hit a button and it's updating the LCD, it's 8.3 milliamps for less than a second. So it is a little bit of a peak, and then it goes back down and settles and goes to sleep. So really, even if you're continually changing screens and stuff, it's not really drawing that much current. If you're transmitting through a serial port, I'm not going to tell you how that's done. It's 6.7 milliamps.
And you're not going to tell them because?
Because it's a secret.
You guys writing that down?
Yeah, secret. And you maybe will figure it out, maybe not. I'll tell you at closing ceremony is what it's for. So you can use this thing for 2 weeks, which is cool, and I'm really happy with how it turned out. And in say you have typical daily use of an hour active, which means an hour of the display updating constantly, which you're probably not going to sit there and update it for an hour. But even if you do, it's still going to last 9 days. Here's a little power consumption chart for a single LCD refresh. You can see it just sort of peaks and then comes down really quick.